So up next, I would like to welcome Jason Attwood to the stage. He's going to be talking about gaming with the cloud and the unique opportunities there. So please welcome Jason.
All right, let's get cracking. So yes, thanks everyone for coming. This is my talk on leveraging the cloud in gaming applications. I think everyone can still hear me. So yeah, we're going to get right into it. So a little bit about me. My name is Jason. I'm a solutions engineer at Cloudflare in our gaming and iGaming team. That basically means that I help our customers solve their technical problems with Cloudflare. Before Cloudflare, I actually used to work in the gaming industry in esports. So this picture's of a sold-out Wembley Arena for one of the events that I worked on. And I actually worked in the broadcast section. Specifically, it's probably a little bit small, but in the bottom right-hand picture, all the game overlay stuff that was driven by the data from the game, that was all me. So all the game integration stuff. So that's a little bit about me. A little bit about Cloudflare and what Cloudflare actually is, if you're not familiar. Essentially, Cloudflare is a cloud services provider, but really underneath that, Cloudflare is a network, right? So all of these dots on the map are all of our data center locations. We call them POPs, or points of presence. And there are 335 of them around the world across 125 or over 125 countries. And this number is always increasing. With that, we have about 150 terabits per second of network capacity. And due to, it's also one of the most interconnected networks in the world. So we actually have 13,000 networks that make up the internet that are directly connected with our network. And all of that combined means that we're essentially within, sorry if this microphone's being funny, is that we're within about 50 milliseconds of 95% of the world's internet-connected population. So yeah, our services are nice and quick. We've got quite a few customers in the gaming space. Some of our biggest ones include CCP Games, who are the creators of EVE Online and the EVE franchise of games. They've got about 300,000 active players a month, and they're based in Iceland. We also have Cybo, who you might have heard of, who are the creators of Subway Surfer. They're bringing in many more players, 150 million active monthly users. They're based out of Copenhagen. And we also have Discord. I'm sure everyone knows Discord. They've got 200 million active users, and they're based out of San Francisco, or San Francisco. So the point of this slide is really just to iterate that we work with companies of all sizes in the gaming industry, based all around the world. So no matter where you are, we can support you. So that's enough about Cloudflare. What I really want to talk about is games, and specifically online games. So when we talk about online games, we might be thinking of just traditional multiplayer games, right? So you might be thinking of your Call of Duties or your Formula Ones or Valorant or anything that's just like traditionally multiplayer. But I kind of want to expand the scope to include what I've deemed asynchronous multiplayer games. So these are games where you don't necessarily have to be, all the players don't have to be connected at the same time, right, to still play. So examples would be something like Clash of Clans, where you're building your base, and then you can put the game down, and someone else can go and interact with your base, and raid your base while you're not there. Other examples would be turn-based games like Civilization or like chess, for example, right, where you can make your turn, go away, someone else can make their turn, and you can come back and still play the same game. Or other examples would be like racing games with leaderboards or like ghost cars, where again you kind of set your time, and then people can still play. You're still playing the same game, just not at the same time. An honourable mention goes to Bulletstorm. Has anyone played Bulletstorm or is aware of it? Give me a hands up. Anyone? Okay, no one. Okay, so Bulletstorm, the reason it's up there is this honourable mention for me. It's a shooting game, but has this leaderboard system where you're competing for points for basically getting through the levels as quick as you can and creatively as you can. And the reason it's up there is because that's the only leaderboard-based multiplayer that I've ever really gotten into. I had a little competition with my friends at school, who can get the best score on each level, and it was great fun. So that's why it's an honourable shout out. It's a great game if you've not played it. Okay, so we said kind of like the real-time multiplayer and the asynchronous multiplayer games, but I also want to broaden the scope even more to include all types of online features, right? Because even for single-player games, you're kind of hard-pressed to find a game that has absolutely no online component these days, right? Whether it's things as simple as achievements or cloud saves or user analytics and the telemetry, analyzing player habits and how they're interacting with your game to inform future game updates. Everyone's favorite topic, microtransactions, and in-game shops and how you power those. I mean, even in single-player games, it's extremely common, especially recently with the Oblivion remaster. You can go get your horse armor from the in-game shop. Another one, which is another popular topic, is DRM, so digital rights management software for how you basically for anti-piracy uses. Also, social metagames. So I'm not sure if people are familiar, but a game called Helldivers has this sort of social metagame going on where it will look at the levels that the players are playing and sort of use that to dictate future game updates and almost like the game narrative and how the wider story of the game unfolds. And then this other feature that I'm kind of putting into player clues. So this is games like Souls-like games where you can leave clues to interact with other players' games. So you're not in their game directly, but you might be leaving clues or signposts or death recaps, things like that. Are common in games like the Souls series and Death Stranding, games like that. So when you think about all of those features, whatever they are, it kind of all boils down into these three columns, right? First of which being data. You need some data to store and to analyze and do stuff on. You have some custom logic to manipulate that data and take things out of it that you're trying to achieve, and then an API to expose that data to link different systems and actually leverage it. So with that in mind, so we've got our three pillars of our application. We've also got to make some decisions about where we're going to deploy that app, right? So you've kind of got two options. You can deploy it on premises or in the cloud, right? And there are some trade-offs, as with everything in engineering and life. If you're deploying on-prem, you've got to buy the hardware, right? And you have to manage it yourself, which, yes, there is overheads, but there are also benefits, right? There's relatively low ongoing costs. You're not renting anything. You just have to pay for the power. And you have full control and access to the server, right? Like it's your machine, you can do whatever you want to it. If you want to go plug a USB stick in it, go ahead, it's yours. It's literally a box in the cupboard. And then on the flip side of that, in the cloud, you're basically renting the hardware, right? So you don't have any initial outlay, you don't have to buy the hardware, but you do have to keep up with a higher ongoing cost. But that means you're also only paying for your usage rather than having this high power server with all this overhead. Extra power that you might not be using all the time. Especially with game traffic, it can be quite spiky. So there are going to be low times where your powerful server is kind of spinning its wheels and not really doing anything. And also you have the benefit or the downside that you don't have to worry about the server. It means you can't go plug a USB stick into it. But maybe that's a benefit as well because someone else is handling that for you. And realistically, what it comes down to is you're probably going to go for a hybrid approach where some applications make sense to have on premises and some make sense to have in the cloud. Okay, so we've now decided whatever our decision was. We've got our application, we know the three parts, and we've deployed it somewhere, either on premises or in the cloud. And now we should change our mindset a little bit into how we're going to secure that application. So you might say, we're going to put some authentication and some authorization on it. The difference being, think of it like a bouncer outside a business. Authentication is checking people are authentic and they are who they say they are, i.e. the person on the ID is the person you're talking to. And authorization is that person, now we know who they are they allowed to access what they're trying to access? So that's all well and good. We can make sure the right people are trying to interact with our application or our service, but that doorman, right, if you like, those services that are those endpoints are still open to the internet, right? Anyone can attack them. And so just like if you had thousands of people come up to this one doorman who's trying to let people into your business, he's going to get pretty overwhelmed, and that's going to slow the flow of people coming in, right? And it's the same in the technical world, right? So you have volumetric attacks. So you might have heard the term DDoS attacks, distributed denial of service attacks, which is basically flooding a given service with lots of traffic, and with the idea of taking it offline because it's so busy trying to process all these malicious requests, it can't service the legit ones. Then some other attack vectors that you see are credential stuffing, where an attacker will take leaked credentials, so usernames and passwords from known data breaches, and just try and stuff them into a service, right, on the odd chance that someone's reused a password, and they can gain access and take over the account. And then on that note as well, phishing. I'm sure everyone knows what phishing is, and all the emails that you get probably daily. Just wanted to highlight it here because it's still the #1 attack vector in the cybersecurity space. And of course, all of this stuff has business implications, right? So if your service gets attacked that's running your shop, for example, and that's your revenue source, that goes offline, that's bad news for the business, right? And also in gaming, if your service goes offline, players can't play, they're going to lose faith, probably move to a different game, maybe never come back. That's a lost player and a lost customer. This is my PSA slide. So if anyone who's not seen this website before, this is basically a site where you can check if your credentials, if your username has been part of a known data breach. So you can put your email in, and then it will come back with a list and tell you if your email address was found in a known breach, and it will tell you when it occurred, what the source was, and what was leaked. It's really good, but also quite scary because I, for one, my stuff has been leaked many times over, and the recommendation is to change your passwords and keep them unique. Okay, so now we've kind of spoke about security. Now I want to pivot and talk about performance as well. And so what are some ways that we can improve performance of our web applications? So the first one being caching, which is basically if we have content that's common to a lot of people, rather than everyone going to the source and getting that information, we can put a caching layer in, right, and just serve that same content almost as an intermediary and push that out to everyone who's trying to see the same thing because it's the same for everyone. We can also look at optimizing the routing across the internet. So the internet's made out of lots of different networks, and traffic makes a lot of hops across the network, and we can optimize that path, right? So eliminate unnecessary hops or maybe longer hops. And then you can also think about offloading application logic, right? You can scale your infrastructure so it's more powerful and can process things quicker, or you can distribute it, right, and move it across different servers to optimize it that way. Cool, so now we've got all these problems, we've got these security problems, these performance problems, so how can Cloudflare help? So just taking a little step back, I said that Cloudflare is a network, and what that really looks like in an application layout is this. So Cloudflare sits in between your users and your infrastructure, right? Your origin labeled in here, and it acts as a proxy, right? So that means all the requests and all the traffic going through we see as an intermediary, and that lets us do things like caching, like doing that route optimization, and that security step as well, blocking any malicious traffic. Again, this is our network, and these are all our locations. And what makes the Cloudflare network unique is that it's structured on an Anycast system. I know the slide might be a little bit small, but essentially the way it usually works is one machine somewhere in the world will have one IP address, right? And you make a request to that IP address, and it goes. And if that IP address is in Turkey or in Brazil or in China, that's where it goes. Cloudflare works a little bit differently in that all of our POPs in our network have the same IP address, and depending on where you are and who you ask, essentially where this IP address is, you'll get routed somewhere else. Think of it as like asking someone where the nearest McDonald's is, right? They're not going to tell you where the one in Turkey is. They're going to tell you where the closest one is down the road. And the Cloudflare network works exactly the same, which means that you get the quickest performance, right? Because your traffic isn't going to the other side of the world. It's coming back from just down the road. Okay, and so we use this. We use our network to run or to provide a whole load of different services. So on the rightmost column, we've got our application services, which are really focused on what I covered earlier in terms of the performance and security optimizations. We've got some networking stuff in the middle that I'm not going to cover. On the left, we've got our zero trust services, which are really focused around securing your infrastructure. So if you've got applications that you use internally, we've got a whole suite of products around securing those. But the one I really want to dive into a bit more is this bar underneath that says Cloudflare Edge Developer Platform. And that's basically our offering for building applications on the edge and on our network. So, as I said, it's the developer platform, and what it's really focused on is our product called Workers. Now, Workers is sort of our serverless function product. So think if you're familiar with AWS Lambda, it's similar to that, in that you can write application code and it will run in the cloud, and it will also be deployed across our whole network. So it's not you make a request and it goes to the other side of the world. Again, it will run local to where your user's making that request, which makes it really speedy. I want to dive in a little bit into the technical. Can read through this slide, but essentially the takeaway is for a lot of cloud-based logic, they use a container model where basically every process has an amount of overhead associated to it. So when a new process gets spun up, you have to reapply all that overhead for each process. Workers works a little bit differently in that each process is still self-contained, so you can't, they're not talking to one another, but you only have that one set of overhead, which means they fire up really quick and can get right to doing the work right away and super speedy. Another unique aspect of Workers is how we price it. So with a lot of cloud logic providers, you get charged for the whole request duration, right? So you make a request to your Cloudflare worker, and maybe it goes and talks to a database or another function or a third-party API, whatever it may be, and you'll get charged for the whole time. Whereas with Cloudflare Workers, you only get charged for the working time. So if you make a request to a third-party API and you've got to wait, say, 200 milliseconds for that API to get back to you, you're not getting billed on that time when the worker's just waiting. So similar to how I said Cloudflare works with being a proxy and sitting between your users and your web application, it's similar to how Workers works, right? So the events come in on the left side, hit the worker in the middle, and then go and interact with another web application, right? It might be a database, might be a third-party API. Also in the middle, you can see that Workers are written in JavaScript, or you can also Workers also supports WebAssembly, which means you can write in any language that can compile down to WebAssembly. So what can you achieve with Workers, and what are some of the common use cases? Here you can see a setup for doing like A/B testing, right? So say you've got a new product that you want to incrementally roll out some users to and get some testing to. You can do that, right? You have 90% of the traffic go to one version and 10% to another. But really, you can build pretty much whatever you want with Workers, right? Here are some common use cases, but say for a gaming use case, you could run the shop from Cloudflare, right? You could serve different content to different users based on their location, or in the A/B case, maybe you wanted to test different thumbnails for in-game items, something like that. Really, the world's your oyster, and you can use it however you see fit. It really is a platform for you to deploy your logic to. So that kind of covers off the logic part and the API, right? The workers are exposed, and you can make requests to them and develop your own logic. So what about the data column? So we've got you covered there as well with a few different products depending on the shape of your data and what form it takes. So D1 is our SQL database. If your data is well structured, durable objects is sort of the stateful brother to workers. So workers are stateless. You make a request to them, do some processing. But if you need some longer lived state, maybe to coordinate a WebSockets session or something like that, you can use durable objects for that. Hyperdrive optimizes your database queries. So say you've already got a database, Hyperdrive will cache and speed up the existing requests. KV is just key value store. It's just for saving configuration files, but it's super quick and localized. And then R2 is similar to S3 if you're familiar, but this is our just object storage. So this is for files that you can store in the cloud. Yeah. And you can put it all together to make a full application, right? So you can use the application services at the front, write your custom logic, have the data hosted in one of the storage solutions, and then connect it to your analytics tools as well. So yeah, the option is pretty broad depending on how far you wanna take it. And a bit of an announcement, next month, say you've got a application already that uses containers and you don't want to port everything to the cloud specifically, you can deploy your containers on Cloudflare network from next month. Maybe you're thinking about, it sounds good, but how big is it? We've currently got 3 million developers, including some of our biggest clients, working on the developer platform. So it's well established. It's been going since 2019 and is always getting updated. So that's really all I've got. I welcome you to sign up to a free account. When it comes to the developer platform, you can pretty much do anything on the free plan. I think you get 100,000 requests a month or something. So yeah, I invite you to sign up and see what you can build with Cloudflare. So thank you very much. And yeah, if anything has piqued your interest, we've got a booth just over there, so come have a talk.